Okay, so in this tutorial, we are going to solve this question in which we are given with the discrete time LTI system modeled by the difference equation. And this is the difference equation that is given to us. In the part A, we need to find the zero input response. So let's just start this. As the name suggests, we need to find the zero input response, which means x of n equals to 0. So I can write this equation again as y of n minus y of n minus 1 plus 2 by 9 y of n minus 2 is equal to 0. And why is this? Because we are given with the in 0, we need to find the zero input response, and we know that x of n is equals to 0. So I put x of n is equals to 0 here. Now from this such equation, we can write the characteristic equation, and what we can do is we need to put y of n is equals to r of n. So when y of n is equals to r of n, that means y of n minus 1 will be r of n minus 1. So I put in place of n, I put n minus 1 and n minus 1. And similarly, y of n minus 2 will be r of n minus 2. So I can put all these values in the above equation. It will becomes r of n minus r of n minus 1 plus 2 by 9 r of n minus 2 equals 0. Now what we need to do is we need to get rid of this term, right? To make it an equation that I can find solutions. So, okay, so I can find the solution of the equation if I remove these negative terms. So I take this r of n minus 2 common. So because I'm taking n minus 2 common, so I'm gonna, write this as r of 2. So because I removed minus 2 from each terms, so if I remove minus 2 from each term, sorry, because I'm removing n minus 2 from here, so I'm going to add 2 to every point. So that means this is r of 2. Similarly, if I add plus 2 to this term, this will become r of 1. I removed n minus 1 and put 1 here. And I remove the whole thing, this r of n minus 2 out, so it will become 2 by 9 equals to 0. And let me just show how this thing will again make this thing. So because these two are multiplying, so that means r of n minus 2 multiplied with r square, so it will becomes r of n minus 2 plus 2. So this term will cancels out and it will becomes r of n again, right? Similarly, r of n minus 1 multiplied with r of n minus 2. So sorry, it has to be r of 1. So if I multiply this r of 1 with r of n minus 2, it becomes r of n minus 2 plus 1, and it will becomes r of n minus 1 again. And if I multiply this with this, we'll get the same thing again. So this thing is equals to these things. So I can remove this guy because this will go here and multiply with 0. So this will becomes r squared minus r plus 2 by 9. Now I can solve this equation on calculator, and if I solve this on calculator, I'll get the two roots as r1 is equals to 1 by 3 and r2 is equals to 2 by 3. Okay, so we get the two roots, which was expected because it was given in the question as well. So I just shown you how to obtain these two roots. So once we got the roots, the next thing is we need to write the general solution. So the general solution, when the roots are real and distinct, so they are real and distinct, right? They are real and they are not same, so they are distinct. So the roots in the general solution in such a situation is given by y of n equals a, the first root power n, plus b, the second root power n. Okay, so this is the general solution. Now we need to find the constants a and b, and we are also given with the initial conditions. So we'll use these initial conditions to get a and b. This general solution is valid only if the roots are real and distinct. The roots could have been 1 by 3 and 1 by 3. In that case, this equation is not valid. The roots could have been complex, 5 plus minus 2 iota. So the roots won't, the general solution won't be valid for that case as well. So this is only valid for this case when the roots are real and distinct. Okay, so now we know the general solution. Now we'll use these initial conditions to obtain a and b. So let's just first use the first initial condition, which is y of minus 1 equals 0. This is our first initial condition. So we need to put minus 1 in the y equation. So if we put y of minus 1 here, y of minus 1, we put everywhere minus 1, wherever is n. So we replace n with minus 1. Okay, so if I replace n with minus 1, I'll get a 1 by 3 minus 1 plus b 2 by 3 minus 1. And we know that minus y of minus 1 is equals to 0. And this is minus 1, so I can take that in the denominator. The power will get positive. And I can take this thing in the denominator as well. So the power will become positive. So that means 0 is equals to 3a plus 3 by 2 plus 3 by 2b. So this is our first equation. Now I cannot obtain a or b because there are two unknowns and we only have one equation. So for that, I'm going to use the second initial condition, y of minus 2 is equals to 1. Now we put this in this equation, so it will become y of minus 2 is equals a 1 by 3 minus 2 plus b 2 by 3 minus 2. So I can write it because y of minus 2 is equals to 1. So 1 is equals to a, this term will go into the denominator, square, plus this term will go into the denominator, square. Okay, now if I solve this term 1 by 3 squared is 1 by 9, and 9 goes into the denominator. So 9a plus 9 by 4b. Now we have two equations and we have two unknowns. So I can solve for a and b. Now what I'll do is I'll multiply this equation with 3. So this will become 9a plus 9 by 2b. Okay, so I multiplied this with this and this becomes this. Okay, now I'm going to subtract these two equations. Okay, so I'm going to subtract these two equations, which means I'm going to write this equation under this. So 1 is equals to 9a plus 9 by 4b. So if I subtract these two, this will become minus 1. This will be cancels out. And 9 by 2 minus 9 by 4 is equals to 9 by 4b. So I can get the value of b is equals to minus 4 by 9. So now once I get the value of b, I can obtain the value of a by putting it here. So 0 is equals to 3a plus 3 by 2 minus 4 by 9, which means 0 is equals to 3a plus, or we can write minus 12 by 18, or I can write 0. I can also write it as 0 is equals to 3a let me remove this, 3a minus 2 by 3, so that becomes 2 by 3 is equals to 3a, and this 3 is multiplying as it will be dividing there, so a is equals to 2 by 9. So we got both the a and b. We can put them in this equation to get y of n equals 2 by 9, 1 by 3 power n plus, not plus actually, it's minus 4 by 9, 2 by 3 power n. So this is our y of n. So we have obtained the y of n from the given difference equation. We got our first result. We obtained the zero input response. It is a zero input response because the input was 0. In the second part, it says, is this system internally stable, unstable, or marginally stable? So because the roots in the part B or eigenvalues was 1 by 3 and 2 by 3, and the system is discrete time. So the condition for stability is all eigenvalues should be less than 1. So if they are less than 1, they are stable. Equals to 1, any one value equals to 1, it's marginal stability. Any one is greater than 1, it is unstable. So in our case, we see that 1.3 corresponds to 0.33 and this corresponds to 0.66. So because they are less than unit circle, which is 1, the system is internally stable. Okay, so that's it with this question. With this, we end this tutorial.